June 24,
Inside the
1942.
steel heart of the vessel,
Somewhere
precision
beneath
was
the cold
everything.
waters of the
Each
North Atlantic,
calculation, a matter of
Captain
life
Lieutenant
or
Hans
death
Weber
beneath the
watched
waves.
through his periscope as another
Beyond the
Allied
battle
convoy
lines,
passed
another war
overhead
was being
completely
fought.
untouched.
A war of numbers.
He had fired
of
8
logic,
torpedoes
of
in the
code.
last 72 hours. 8 G7E electric torpedoes, Germany's most advanced underwater weapon, the pride of the Kriegsmarine. 0 hits, 0 explosions, just silence, and the sickening realization that somewhere deep in the darkness, millions of Reichsmarks worth of ordnance had simply vanished into failure. This wasn't supposed to happen. German engineering was legendary, precise, mathematically perfect.
Disciplined.
Yet here they were, submarine commanders
Decades
across the
later,
Atlantic,
the truth
sending
surfaced
desperate
upon,
coded messages back to
bound not
Kiel,
in steel
back to
or
Berlin,
gunpowder,
all saying the
ink
same impossible
and
thing: our torpedoes don't work. By the summer of 1942, the statistics were catastrophic. More than 70% of all German torpedoes fired at Allied targets either missed completely, ran too deep, or failed to detonate on impact. 70%. That meant for every 10 torpedoes launched, only 3 had any chance of hitting their mark. The rest: wasted steel, wasted explosives, wasted opportunities. And with each failure, Allied convoys grew bolder, supply lines strengthened, and the window for German naval dominance closed tighter. But what no one in the Kriegsmarine High Command could explain was why. Why did torpedoes that worked flawlessly in Baltic test ranges fail catastrophically in actual combat? Why did depth settings calibrated to perfection in laboratories send weapons harmlessly beneath enemy hulls? Why did magnetic detonators designed to trigger under a ship's keel instead explode prematurely, or not at all? The answer to these questions lay not in the hands of admirals or engineers, but in the calculations of a 31-year-old woman named Margarete Ziegler, a mathematician who had never seen the ocean, never fired a weapon, and whose existence was so carefully hidden that even today most historians don't know her name. If you think a woman with nothing but pencil and paper could expose a $100 million military disaster and save 12,000 lives, comment the number 7 below. If you believe that sometimes the most dangerous weapon in war is the truth, hit the like button. Because what you're about to hear is the story of how one forbidden calculation changed the entire course of the Battle of the Atlantic. The year is 1939 and Europe is burning. Poland has fallen in 27 days. France will follow within months. The Wehrmacht rolls across the continent like an unstoppable machine. But Germany's true strategic weapon isn't its tanks or its aircraft. It's the U-boat, the Unterseeboot, the submarine fleet that can strangle Britain's supply lines and starve the island nation into submission. Admiral Karl Dönitz, commander of the U-boat fleet, has a strategy called Rudeltaktik, the wolf pack. His submarines hunt in coordinated groups, surrounding convoys, attacking from multiple angles, disappearing into the depths before escorts can respond. On paper, it's brilliant. In practice, it requires one critical element: torpedoes that actually explode. But they don't. From the very first months of the war, U-boat commanders report the same nightmare. Torpedoes that strike a ship's hull and bounce off without detonating. Torpedoes that explode 50 meters short of the target, triggered by nothing but empty water. Torpedoes that run 10, 15, even 20 meters too deep, passing harmlessly beneath their targets. The reports flood into headquarters at Kiel. Korvettenkapitän Wilhelm Schultz fires 6 torpedoes at a British destroyer at point-blank range. 4 miss completely. 1 explodes prematurely. 1 hits, but fails to detonate. Kapitän Leutnant Friedrich Guggenberger attacks a convoy off the coast of Scotland. 8 torpedoes fired. 2 premature explosions. 6 duds. 0 sinks. Oberleutnant zur See Joachim Schepke, one of Germany's most decorated U-boat commanders, sends a message that will become infamous. I could have destroyed the entire convoy if my weapons had worked. Instead, I accomplished nothing. The pattern is undeniable, but the Kriegsmarine refuses to see it. At the Torpedoversuchsanstalt, the torpedo testing facility in Eckernförde, engineers insist the weapons are perfect. Every test torpedo functions flawlessly. Every depth setting is mathematically precise. Every detonator mechanism operates within tolerances. The problem, they conclude, must be the commanders. Poor aim. Insufficient training. Combat stress affecting judgment. In September 1940, after a particularly catastrophic series of failures during the invasion of Norway, Admiral Dönitz finally demands answers. He convenes a technical review board, assembles Germany's top naval engineers, and presents them with 6 months of failure reports. The engineers spend 3 weeks analyzing the data and conclude operator error. Dönitz explodes with rage. He knows his commanders. These are not incompetent men. These are hunters-killers, the best submarine officers in the world. If they say the torpedoes don't work, the torpedoes don't work. But without proof, without mathematical evidence, his complaints go nowhere. The torpedo production continues unchanged. The failures continue. And somewhere in the cold mathematics of probability, 12,000 German sailors are being sentenced to death by a weapon that refuses to function. Then, in October 1940, something unusual happens. A 28-year-old mathematician named Margarete Ziegler receives a transfer order from her position at the University of Göttingen to a classified facility outside Kiel. She doesn't know why. She's never worked on military projects. Her expertise is in applied physics and statistical analysis, obscure fields that seem irrelevant to warfare. When she arrives at the facility, she's told her assignment analyze torpedo test data for quality control. It sounds bureaucratic, tedious, the kind of work meant to keep women busy while men fight the war. She's given a small office, a desk covered in filing cabinets, and strict orders not to discuss her work with anyone. For the first 2 weeks, Margarete does exactly what she's told. She reviews test data from Eckernförde, checking calculations, verifying measurements, ensuring that each torpedo meets specification. Everything looks perfect. Depth control mechanisms calibrated to within half a meter. Detonator timing accurate to milliseconds. Propulsion systems tested across multiple temperature ranges. The torpedoes should work. But then she asks a question no one has thought to ask: why are the test conditions different from combat conditions? The Baltic Sea, where all torpedoes are tested, is shallow, cold, and has a different water density than the North Atlantic. The test ranges use stationary targets or slow-moving barges, not fast warships executing evasive maneuvers. The magnetic detonators are calibrated to the Earth's magnetic field at 54 degrees north latitude. But most combat occurs between 40 and 60 degrees, where the field strength varies by nearly 15%. She starts pulling combat reports, comparing them against test data. The discrepancies are immediate and shocking. In Baltic tests, torpedoes run at their set depth with 98% accuracy. In Atlantic combat, they run an average of 12 meters too deep. In Baltic tests, magnetic detonators trigger within 3 meters of a steel target. In Atlantic combat, they trigger randomly, sometimes 50 meters away, sometimes not at all. In Baltic tests, contact detonators function perfectly at impact speeds up to 40 knots. In Atlantic combat, they fail 70% of the time on high-speed hits. The pattern is undeniable, mathematical, irrefutable. But when Margarete presents her preliminary findings to her supervisor, he dismisses them immediately. The Torpedoversuchsanstalt has been testing weapons for 20 years, he tells her. If there were problems, they would have found them. She tries again, showing him the statistical correlations, the probability curves, the fact that combat failures cluster precisely in conditions that differ from test parameters. He closes her folder without reading it. Your job is to verify existing data, not to question naval engineering. She should stop. She should return to her desk, stamp the reports as approved, and collect her salary. Instead, she does something insane. She begins conducting her own analysis, secretly using combat data she's not supposed to access. Every night, after the other staff go home, Margarete stays in her office with the lights dimmed. She's discovered that combat reports from U-boat headquarters are stored in an adjacent building, filed under operational security, but not actively guarded. Over 3 months, she copies hundreds of reports by hand, transcribing every failure, every depth setting, every sea condition, every magnetic anomaly. The work is exhausting, dangerous, and completely unauthorized. If caught, she could face charges of espionage imprisonment, or worse. But the numbers won't let her sleep. She builds mathematical models in her notebooks calculating how water temperature affects torpedo buoyancy, how salinity changes pressure readings, how magnetic field variations alter detonator sensitivity. She plots failure rates against latitude water depth, target speed, and impact angle. By January 1941, she has constructed a complete predictive model that explains every single torpedo failure reported in the Atlantic. The problem isn't one flaw. It's 3. First, the depth control mechanism uses a pressure sensor calibrated in cold Baltic water. When the torpedo enters warmer Atlantic water, the sensor reads pressure incorrectly, causing the weapon to run 12 meters deeper than set. Second, the magnetic detonator is calibrated to the magnetic field strength at German latitudes. In the mid-Atlantic, where the field is weaker, the detonator either fails to trigger or triggers prematurely on random magnetic anomalies. Third, the contact detonator uses a firing pin that's too rigid. At high impact speeds above 35 knots, the pin jams against its housing instead of striking the primer. The faster the torpedo hits, the more likely it fails. Her calculations are precise mathematical and completely contradictory to 2 years of official testing. On February 3, 1941, Margarete does something suicidal. She writes a 14-page technical memorandum detailing her findings and mails it directly to Admiral Donitz's headquarters in Paris. No approval from her supervisors. No authorization from the Kriegsmarine. Just her calculations, her data, and a single sentence at the end. These failures are not operator error. They are design flaws that can be mathematically corrected. For 6 weeks, she hears nothing. Then, on March 18th, 2 officers from Naval Intelligence arrive at her office unannounced. They confiscate her notebooks, her files, every scrap of paper containing her analysis. They inform her that unauthorized dissemination of classified information is a criminal offense. They tell her she's being transferred immediately to Berlin for administrative review. As they escort her from the building, she's certain she's about to be arrested, possibly executed. Instead, she's taken to a conference room in the Kriegsmarine headquarters, where Admiral Dönitz himself is waiting. He's surrounded by senior engineers, all of them looking at her with expressions ranging from curiosity to hostility. Dönitz slides her memorandum across the table. "Fräulein Ziegler," he says quietly, "I have read your analysis 3 times. My engineers tell me you're wrong. They say our torpedoes are perfect and that you've misunderstood the data." He pauses, studying her face. "But I have 140 U-boat commanders who say you're absolutely right." The room goes silent. One of the engineers starts to object, but Dönitz cuts him off with a gesture. "I'm going to ask you a question," Dönitz continues, "and I want an honest answer. If we implement your corrections, will our torpedoes work?" Margarete looks at the men around the table, all of them waiting for her to fail to backtrack to admit she was mistaken. Instead, she reaches into her briefcase and pulls out a single sheet of paper covered in equations. "Admiral," she says, her voice steady despite her fear, "if you adjust the depth control spring by 18%, recalibrate the magnetic detonator for Atlantic field strength, and soften the contact firing pin by 40%, your torpedoes will function with 95% reliability." She places the paper on the table. "But you'll have to test them in actual ocean conditions, not the Baltic. And you'll have to admit that 2 years of testing were based on flawed assumptions." The silence that follows is so heavy, it feels physical. Then Dönitz does something no one expects. He smiles. "Gentlemen," he says, turning to his engineers, "we're going to do exactly what she says. And if she's wrong, I'll take full responsibility. But if she's right..." He looks back at Margarete. "If she's right, we're going to win this war." What Dönitz didn't say, what he couldn't say in that room full of proud engineers, was that he had no choice. The torpedo crisis had become so severe that U-boats were returning to port with full loads of unused weapons because commanders refused to waste them on targets they couldn't hit. The Battle of the Atlantic, Germany's greatest strategic advantage, was being lost not to British destroyers or convoy tactics, but to torpedoes that didn't explode. Within 48 hours, Dönitz orders an emergency test program. 3 U-boats are equipped with modified torpedoes based on Margaret's calculations. The modifications are crude, done by hand in the workshops at Lorient, but they follow her specifications exactly. Depth springs adjusted 18%. Magnetic detonators recalibrated for 50 degrees north latitude. Contact firing pins softened with a heat treatment process. On April 2, 1941, U-552, under the command of Kapitän-Leutnant Erich Topp, encounters a small convoy southeast of Iceland. He fires 4 modified torpedoes. All 4 hit. All 4 explode. 3 merchant ships and 1 destroyer sink within 15 minutes. But this is only the beginning, because what happened next would turn the Atlantic into a graveyard for Allied shipping and prove that sometimes the most powerful weapon in warfare isn't steel or explosives, but mathematics, wielded by someone brave enough to challenge authority. In Part 2, you'll discover how Margaret's corrections transformed the U-boat fleet into the deadliest force in naval history. How the Allies struggled to understand why German torpedoes suddenly became unstoppable, and how one woman's forbidden calculations created a crisis that would eventually lead to the invention of technologies we still use today. You'll also learn why the German High Command tried to erase her from history, and how her work nearly cost her everything. In Part 1, we met Margarete Ziegler, a 31-year-old mathematician who discovered why 70% of German torpedoes were failing catastrophic design flaws hidden in the mathematics of depth control, magnetic detonation, and contact firing mechanisms. Her calculations convinced Admiral Dönitz to authorize emergency modifications. U-552's first combat test on April 2, 1941, seemed to prove her right. 4 torpedoes, 4 hits, 4 explosions, 4 ships sunk. But convincing one admiral with one successful test is not the same as changing an entire naval institution. The Kriegsmarine had invested 100 million Reichsmarks in the G7E torpedo program over 8 years. Admitting fundamental design flaws meant admitting systematic failure at the highest levels of German engineering. And the men who had approved those designs, who had certified those tests, who had dismissed 2 years of combat complaints, were not about to surrender their reputations to a woman with a notebook full of equations. What Margaret didn't know yet was that her greatest battle wasn't against Allied convoys or faulty torpedoes. It was against the bureaucracy that would rather see men die than admit it was wrong. And this is where everything becomes worse than anyone could imagine. Admiral Wilhelm Canaris, head of the Abwehr military intelligence, sits in his office in Berlin, reviewing Margaret's technical memorandum. He's not reading it to understand the mathematics. He's reading it to understand the threat. On his desk lies a confidential memo from the Torpedoversuchsanstalt, signed by Konteradmiral Oskar Kummetz, the officer who had overseen torpedo development since 1936. The memo is 3 pages of dense technical jargon, but its conclusion is brutally simple. Fräulein Ziegler's analysis is based on incomplete data and fundamental misunderstanding of naval engineering principles. The current G7E design is optimal and requires no modification. Kummetz has staked his entire career on the perfection of German torpedo technology. He has published papers. He has received commendations. He has personally assured Gross Admiral Erich Raeder, commander of the entire Kriegsmarine, that Germany's underwater weapons are superior to anything the British or Americans possess. Now, a civilian mathematician with no naval experience is suggesting that 8 years of his work is mathematically invalid. The institutional response is immediate and brutal. On April 15, 1941, Margaret receives a formal letter from the Kriegsmarine Personnel Office. Her temporary assignment to the Torpedo Analysis Division is terminated. She is to return immediately to Göttingen University and resume her academic position. Any further discussion of classified military matters will be treated as a security violation. She reads the letter 3 times, unable to believe what she's seeing. They're not just dismissing her findings. They're erasing her existence from the program entirely. That afternoon, she requests a meeting with her supervisor. He refuses. She writes directly to Admiral Donitz's office. Her letter is returned unopened with a stamp, "Correspondent no longer authorized for classified communication." It takes her 2 days to understand what's happening. Donitz may have been convinced by her analysis, but he's only one man in a hierarchy of admirals, bureaucrats, and engineers who see her work as an existential threat. The U-boat command wants to implement her corrections. The torpedo establishment wants to bury them. And somewhere in Berlin, men in offices are deciding which faction wins, not based on mathematics or combat effectiveness, but on politics and institutional pride. On April 20th, she does something reckless. She travels to Lorient, France, where U-552 is docked after its successful patrol. She has no authorization, no travel papers, no official reason to be there. She simply boards a train carrying a briefcase full of her calculations and hopes no one asks too many questions. When she arrives at the submarine pens, she's stopped immediately by naval police. "Fräulein, this is a restricted military zone." She hands them a letter she's forged using official stationery from her old office, claiming she's conducting follow-up analysis on recent torpedo performance. The guards are suspicious, but uncertain. A woman alone at a submarine base, it's unusual enough that they don't know how to respond. While they're debating what to do with her, a voice calls out from behind them, "Let her through!" They turn. Standing at the entrance to the pens is Kapitänleutnant Erich Topp, commander of U-552. He's younger than she expected, maybe 35, with the kind of face that's seen too many depth charge attacks. "You're the mathematician," he says. "It's not a question." She nods, uncertain. "I read your memorandum," Topp continues. "Someone at headquarters sent me a copy before they tried to classify it." He lights a cigarette, studying her with the calculating gaze of someone who trusts numbers more than people. "Your corrections worked. 4 shots, 4 kills. First time in 18 months I didn't have to apologize to my crew for wasting torpedoes." He gestures toward the submarine. "Come on, I'll show you something." Inside U-552's torpedo room, Topp shows her the modified weapons crude adjustments made by hand in a dockyard workshop. "Your depth spring calculation," he says, pointing to a mechanism that's been manually compressed and locked with a bolt. 18%, just like you said. We tested it at sea before the attack. Ran perfect at 20 meters. He moves to the next torpedo. Magnetic detonator recalibrated for Atlantic field strength. We had to file down the sensor housing to reduce sensitivity. Not elegant, but it worked. Then he looks at her directly. The brass wants to pretend this never happened. They want to say the original design was fine, and we just needed better training. But I've got 47 men on this boat who are alive because your mathematics were right, and their engineering was wrong. But Topp alone can't change naval policy. What Margarete needs is someone with enough rank to force the issue, someone willing to stake their career on her calculations. That someone arrives 3 days later in the form of Korvettenkapitän Victor Uern, Donitz's chief of staff for U-boat operations. Uern is a combat veteran, a pragmatist, and a man who has watched too many commanders return from patrol with reports of torpedo failures. When Donitz tells him about Margarete's analysis and the institutional resistance, his response is immediate. Then we prove it again, publicly, with enough witnesses that no one can deny it. He proposes something unprecedented, an official comparative trial. 3 U-boats, 3 identical attack scenarios, 3 different torpedo configurations. Boat 1 standard factory torpedoes exactly as delivered from Eckernford. Boat 2 torpedoes modified according to Margarete's calculations. Boat 3 torpedoes with the modifications the Torpedo-Versuchsanstalt claims will solve the problem's incremental adjustments to existing designs without admitting fundamental flaws. Each boat fires at the same type of target under identical conditions. The results are measured, recorded, and witnessed by representatives from the High Command, the torpedo establishment, and independent naval engineering observers. One test, one chance. Winner takes all. The torpedo establishment agrees, confident their incremental improvements will prove sufficient. They have no idea they're about to be mathematically humiliated. The test is scheduled for May 8, 1941, at a range off the coast of Brittany. The target, 3 obsolete French cargo ships captured during the invasion, each roughly 8,000 tons, anchored in a line 200 meters apart. The test protocol is brutally simple. Each U-boat surfaces at exactly 1,000 meters from its assigned target. Each fires 3 torpedoes at 30-second intervals. Success is measured by 3 criteria: percentage of torpedoes that run at correct depth percentage, that detonate on or near target, and total destructive effect. Margarete is not officially invited, but Uern arranges for her to observe from a naval patrol boat positioned 3 kilometers from the test range. She stands on deck with her notebook, watching through binoculars as the 3 U-boats take their positions. The morning is cold, overcast, with a light chop that makes the patrol boat rock gently. On the bridge above her, naval observers set up cameras and recording equipment. Admiral Kummetz is there representing the Torpedo Versuchsanstalt, looking confident and slightly annoyed that this demonstration is even necessary. Kapitän zur See, Hans-Georg von Friedeburg, represents the High Command. Uern represents U-boat operations. At your 900 hours, the first U-boat fires standard factory torpedoes. Margarete watches the white tracks cutting through the water toward the leftmost cargo ship. The first torpedo passes directly beneath the target. No explosion. The second detonates 70 meters short, a premature magnetic trigger. The third hits the hull with a visible impact but fails to explode. The cargo ship sits undamaged, a testament to 2 years of combat failure. On the bridge, Kummetz's expression doesn't change. Environmental variables, he mutters to von Friedeburg. Magnetic anomalies in this area. At 09:15, the second boat fires torpedoes modified per the Torpedo Versuchsanstalt's incremental adjustments. The first runs slightly deep, missing by perhaps 2 meters. The second hits and detonates, blowing a modest hole in the ship's waterline. The third, premature magnetic explosion again. 1 hit out of 3. The cargo ship lists but doesn't sink. Kummetz nods, satisfied. Adequate performance, with further refinement. He doesn't finish the sentence because at 09:30, the third U-boat fires Margarete's torpedoes. The first weapon runs straight and level, exactly 20 meters deep, and strikes the target amidships. The explosion is massive, a column of water and debris erupting 50 meters into the air. Before the spray settles, the second torpedo hits 10 meters forward. Another explosion, this one tearing the bow completely off the cargo ship. The third torpedo, which everyone expects to be redundant, strikes the sinking stern. The ship doesn't list. It doesn't settle slowly. It breaks in half and disappears beneath the surface in under 90 seconds. The silence on the patrol boat is absolute. Margarete lowers her binoculars, her hands trembling. Not from fear, but from the vindication of watching mathematics prove itself in fire and steel. Behind her, she hears Kummetz's voice, tight with something between anger and disbelief. That's not possible. The modifications are too crude. There must be. Von Friedeburg cuts him off. Konteradmiral, I believe the results speak for themselves. He turns to Uern. How many U-boats are currently operational in the Atlantic? 47, sir. Begin implementing these modifications immediately. All boats, no exceptions. Kummetz tries one more time. Sir, with respect, these are field expedient changes, not proper engineering solutions. We should conduct more comprehensive testing. We've been testing for 2 years, von Friedeburg snaps. And for 2 years, our commanders have been firing weapons that don't work. This test proves that Fräulein Ziegler's analysis is correct. Whatever your department did wrong, fix it. But these modifications are now standard protocol. The institutional war is over. Margarete has won. But the real war is just beginning. Over the next 8 weeks, every operational U-boat in the Atlantic receives modified torpedoes. The process is chaotic improvised, conducted in submarine pens from Brest to Bergen, by crews who are learning the specifications as they implement them. Margarete herself travels between bases training mechanical officers on the exact tolerances required for each modification. It's exhausting, dangerous work conducting technical training in active war zones while Allied bombers raid overhead. But the results are undeniable. In June 1941, German U-boats sink 42 Allied merchant ships totaling 208,000 tons. It's the highest monthly total since the start of the war. In July, the number climbs to 51 ships. By August, Allied convoy losses reach crisis levels. The Royal Navy begins diverting destroyers from other theaters just to protect Atlantic shipping lanes. In London, the Admiralty's Operational Intelligence Center notices the change immediately. For 18 months, U-boat attacks have been erratic, unpredictable, with far more misses than hits. Starting in May 1941, the pattern shifts dramatically. German torpedoes are suddenly running at correct depths. Detonation rates jump from 30% to over 90%. Hit probability nearly triples. The analysts can't explain it. There's been no new torpedo model introduced, no major tactical change. It's as if the entire U-boat fleet suddenly learned how to aim. What they don't know is that a woman whose name appears nowhere in German naval records has just made the Battle of the Atlantic vastly more lethal. But success breeds new problems. In September, a modified torpedo from U-96 fails catastrophically during an attack on convoy SC-42. Instead of detonating on impact, it circles back toward its own submarine. The crew executes an emergency dive, and the torpedo passes overhead by less than 3 meters. When Margarete reviews the failure report, she realizes the problem immediately. Her modifications assume careful, precise implementation. But under combat conditions, with limited tools and rush training, some crews are making errors, calibrating springs too far, weakening firing pins too much. One success rate improves, but new failure modes appear. She writes another memorandum, this one detailing secondary corrections and stricter quality control procedures. But by now, word of her work has spread beyond the Kriegsmarine. In Berlin, officials at the Reich Ministry of Armaments begin asking questions about the torpedo modifications. Who authorized them? Who designed them? Why was a civilian mathematician involved in classified military development? The answers make powerful people uncomfortable. In October 1941, Margarete receives a visitor at her apartment in Kiel. He's not military. No uniform, no insignia. Just a man in a gray suit with eyes that have seen too many interrogations. "Fräulein Ziegler," he says quietly, "there are concerns about operational security. Your work has been noticed." She understands immediately. Her success has made her dangerous. She knows too much about German naval capabilities, technical specifications, tactical deployment. In wartime, knowledge like that makes you either an asset or a liability. "I'm being reassigned," she says. "It's not a question." "To a position more appropriate to your expertise," the man replies. "Berlin, theoretical mathematics, important work but less direct." It's exile disguised as promotion. Remove her from the submarines, from the combat data, from the place where her calculations have real power. She should protest. She should fight. Instead, she thinks about the 47 men on U-552 who are alive, because her mathematics worked. She thinks about the hundreds more across the Atlantic Fleet, who now have weapons they can trust. And she realizes that perhaps her work is finished. The torpedoes are fixed. The modifications are documented. The war will continue with or without her. "When do I leave?" she asks. "Tomorrow." In Part 3, you'll discover what happened when Margarete's corrected torpedoes turned the Battle of the Atlantic into Germany's deadliest offensive, pushing Britain to the brink of starvation and forcing the Allies to develop entirely new technologies just to survive. You'll learn how Allied intelligence finally discovered the source of the sudden improvement in German torpedo performance and the desperate measures they took to counter it. But you'll also discover the dark side of success. Because as U-boat kills mounted and Allied losses reached catastrophic levels, the German High Command began experimenting with Margaret's mathematical approach on other weapons, other systems, other ways of making warfare more efficient, more lethal, and more devastating. And somewhere in the classified files of 1942, a decision was made that would eventually bring Margaret face to face with a moral question no mathematician should ever have to answer. When your calculations save lives on one side, are you responsible for the deaths they cause on the other? The real battle was only beginning. And this time, the enemy wasn't faulty engineering or institutional pride. It was the mathematics of conscience. In parts 1 and 2, Margarete Ziegler discovered the mathematical flaws killing German torpedo effectiveness, convinced Admiral Dönitz to test her corrections, and survived institutional resistance to prove her calculations in a devastating public demonstration. By summer 1941, every operational U-boat in the Atlantic carried modified torpedoes based on her equations. The result was immediate German submarine attacks became 3 times more lethal, sinking merchant ships at rates not seen since the war began. But when Allied intelligence noticed the sudden spike in torpedo performance, when convoy losses reached crisis levels, when the Royal Navy realized something fundamental had changed in German naval capability, the war entered a new and terrifying phase. This was no longer about fixing broken weapons. This was about survival. And both sides knew it. September 1941. The Admiralty's Operational Intelligence Center in London. A cramped basement room filled with maps, charts, and exhausted analysts. Commander Roger Wynne stands before a wall covered with colored pins, each one representing a U-boat attack. Red pins for confirmed sinks, yellow for damaged ships, white for attacks that missed. For 18 months, the wall had been a chaotic mix of all 3 colors, a visual representation of German torpedo unreliability. But starting in May, the pattern changed. The white pins disappeared almost entirely. Now the wall is dominated by red. Wynne traces his finger along the Atlantic convoy routes, counting the losses. June 42, ships sunk. July 51. August 61. September is tracking to be worse. "They've fixed something," he says quietly to his deputy. "The Germans have solved their torpedo problem. The implications are catastrophic. Britain imports 70% of its food by sea. If U-boats can sink merchant ships faster than they can be replaced, the island will starve within 6 months. Already rationing has been tightened. Butter, meat, sugar, all reduced. The civilian population doesn't panic yet, but the government knows the mathematics of survival are becoming impossible." Winston Churchill will later write that the U-boat peril was the only thing that ever really frightened me during the war. In September 1941, that fear becomes statistical reality. The Royal Navy responds with desperate measures. Convoy escorts are doubled. Destroyers equipped with new ASDIC sonar are rushed into service. Aircraft patrols over the Atlantic are increased. But none of it addresses the fundamental problem: German torpedoes now work with 90% reliability, and British defenses were designed to counter weapons that failed 70% of the time. The mathematics have shifted, and Britain is losing. In Washington, the U.S. Navy, which isn't even at war yet, studies the British reports with growing alarm. American observers note that if the United States enters the conflict, its Atlantic supply lines will face the same devastation. Planning begins for convoy systems, escort carriers, and anti-submarine warfare tactics. But these are long-term solutions. In the immediate present, Allied shipping is being slaughtered, and no one knows exactly why German torpedoes suddenly became so deadly. British intelligence launches Operation Urgent, a classified program to capture an intact German torpedo for analysis. Commando raids target U-boats in French ports. Salvage teams search wreckage of sunken submarines. But the Germans, aware that their improved performance might be noticed, implement strict security protocols. Every torpedo is to be destroyed if capture seems imminent. No complete examples reach British hands. By October 1941, Allied merchant marine losses exceed 400,000 tons per month. Entire convoys are wiped out. The SS Avicida, SS Anavor, SS Silver Cedar, all sunk in a single Wolfpack attack. Survivors report that German torpedoes are running at perfect depth, detonating with terrifying consistency. One merchant captain radios before his ship goes down. They don't miss any more. But the crisis isn't one-sided. In Berlin, the success of Margaret's corrections creates unexpected problems. The modified torpedoes work brilliantly when properly implemented, but under combat conditions with rushed training and improvised tools, errors compound. In November, U-433 fires a modified torpedo that circles back and nearly sinks its own boat. In December, U-577 experiences a premature detonation that alerts a convoy to its position, resulting in a 6-hour depth charge attack. Margarete, now working in theoretical mathematics in Berlin, receives reports of these failures through unofficial channels. Each one confirms her fear, her calculations, assumed precision engineering, and careful quality control. In the chaos of war, those assumptions don't hold. She writes detailed correction protocols specifying exact tolerances for each modification. But her memoranda are now filtered through military bureaucracy. Some reach the submarine pens. Others don't. The institutional machine that once resisted her work now depends on it but implements it inconsistently. Then there's the production problem. Germany's torpedo factories at Eckernförde and Friedrichsort are producing 800 G7E torpedoes per month, but each one now requires hand modification before deployment. The process is slow, expensive, and prone to error. Engineers propose redesigning the production line to incorporate Margaret's corrections directly, but retooling factories during wartime means months of reduced output. The Kriegsmarine faces an impossible choice: continue improvised modifications with inconsistent results, or halt production for redesign while U-boats run out of ammunition. Admiral Dönitz chooses a third option: expand submarine production and accept the modification delays. If individual torpedoes are less reliable, fire more of them. By December 1941, Germany has 68 operational U-boats in the Atlantic, the highest number since the war began. But the human cost is mounting. U-boat crews, emboldened by reliable weapons, take greater risks. They attack larger convoys, penetrate deeper into defended zones, engage escorts directly. Casualties increase. Between June and December 1941, 17 U-boats are lost, more than double the previous 6 months. The families of dead submariners receive letters praising their sons' courage. They don't know those men died because better torpedoes made them too aggressive. In January 1942, Margarete receives an unexpected visitor at her Berlin office. It's Korvettenkapitän Ern Dönitz's chief of staff, the man who had arranged the public demonstration that proved her calculations. He looks exhausted, older than their last meeting. "We need you again," he says without preamble. She looks up from her desk, confused. "I was told my work was complete, that I should focus on theoretical research." Ern places a folder on her desk. "The Americans have entered the war. The U-boat fleet is expanding to 120 boats by March. We're implementing your corrections across the entire production line, but we're seeing failure rates climb in the Caribbean and off the American coast. Different water temperatures, different magnetic conditions. We need your analysis." She hesitates. Part of her wants to refuse to stay in the safe abstraction of pure mathematics. But she opens the folder and sees the failure reports. Torpedoes running too shallow in warm water. Detonators misfiring near the magnetic equator. The same problem she solved for the North Atlantic now appearing in different oceans. "How long do I have?" she asks. 3 weeks. We're launching Operation Drumbeat, the largest U-boat offensive against American shipping, in February. If the torpedoes fail again..." He doesn't finish. They both understand. Thousands of tons of Allied supplies, thousands of lives, all dependent on whether her mathematics work in waters she's never seen. February 13, 1942. Off the coast of New Jersey, U-432, under Korvettenkapitän Hermann Eckhart, rises to periscope depth in darkness. Through the lens, he sees something that makes him doubt his vision, the lights of New York City blazing against the night sky. The Americans haven't implemented blackout protocols. Their merchant ships sail alone unescorted, illuminated against the shoreline like targets in a shooting gallery. This is Operation Drumbeat, Germany's assault on American coastal shipping. 5 U-boats operating in a hunting ground so target-rich, it's been nicknamed the Second Happy Time. But Eckhart isn't confident. He's read the reports of Caribbean torpedo failures. His weapons carry the latest corrections calibrated for warmer water and lower magnetic latitude, but they're untested. At 0147 hours, he fires at a tanker silhouetted against the city lights. The torpedo runs straight. Impact. Explosion. The tanker erupts in flames, oil spreading across the water like liquid fire. Before dawn, Eckhart sinks 3 more ships. All torpedoes function perfectly. The Americans, unprepared for submarine warfare in their own waters, respond chaotically. Ships continue sailing independently. Coastal cities refuse to implement blackouts, fearing economic disruption. In the first 3 months of Operation Drumbeat, U-boats sink over 200 ships along the American coast. The losses exceed anything seen in the Atlantic. Oil tankers, cargo vessels, even passenger ships go down in sight of beaches where civilians watch the explosions. Margaret's corrections, calibrated for tropical and subtropical waters, have turned the American eastern seaboard into a graveyard. But the operation's success creates its own crisis. In March, the U.S. Navy finally implements convoy systems and coastal blackouts. Allied shipyards accelerate production of escort vessels and maritime patrol aircraft. The British share their anti-submarine warfare experience. Slowly, painfully, the Allies adapt. The Second Happy Time ends not because German torpedoes fail, but because American defenses improve. By April 1942, U-boat losses in American waters match their successes. The easy hunting is over. The war has become a brutal calculus of attrition. Then comes the operation that will define the torpedo war. May 2, 1942. Convoy, ONS 92, 43 merchant ships sailing from Liverpool to Halifax. Intelligence suggests a wolf pack of 7 U-boats is converging on the route. The convoy has 8 escort vessels, more than usual, equipped with improved ASTIC and depth charges. The Wolfpack commander is Kapitän Lieutenant Reinhard Hartigan, one of Germany's most successful U-boat aces. He has sunk over 20 Allied ships, but he's never faced a convoy this heavily defended. The engagement begins at dusk. U-123 fires first. 2 torpedoes at a freighter on the convoy's flank. Both hit. Both explode. The freighter sinks in under 4 minutes. Escorts immediately converge, dropping depth charges. Hartigan dives deep, the explosions slamming his boat like hammer blows. 2 hours later, he surfaces 5 kilometers ahead of the convoy and fires again. 3 torpedoes. 3 hits. Another freighter and a tanker go down. The convoy scatters in panic. Throughout the night, the Wolfpack attacks in coordinated waves. U-432, U-94, U-201, U-569, all closing in. Torpedoes cross the water in white streaks. Ships explode. Escorts drop depth charges. The ocean becomes a chaos of fire and steel. By dawn, 11 merchant ships are sunk. But the Germans have paid a price. U-94 is depth charged and sinks with all hands. U-569 is damaged and forced to surface, then destroyed by gunfire from a corvette. Hartigan, in U-123, fires his last torpedo at a straggling tanker. It hits amidships. The explosion breaks the tanker in half, but as Hartigan watches through his periscope, a destroyer appears from behind the burning wreck, bearing down at full speed. Emergency dive. Too late. Depth charges begin falling. The first pattern misses, The second doesn't. U-123's pressure hull cracks. Water floods the control room. Hartigan orders emergency surface. The submarine breaches like a dying whale. The crew abandons ship. Hartigan is the last man off, watching his boat slip beneath the waves. He survives, pulled from the water by the British destroyer. In captivity, he's interviewed by naval intelligence. They ask about the sudden improvement in German torpedo performance. He says nothing, but his silence confirms what the Allies have suspected: something fundamental changed in 1941, and that change nearly cost them the war. The final accounting of Convoy, ONS 92, 11 Allied merchant ships, sunk 86,000 tons of cargo, lost 147 merchant sailors dead. But 3 U-boats destroyed, 2 damaged, and the Wolfpack scattered. It's a Pyrrhic victory for both sides, a battle where success is measured in who loses less. News of ONS 92 spreads through both fleets. For the Allies, it's proof that aggressive escort tactics can counter improved German torpedoes. For the Germans, it's a warning that their technical advantage is diminishing. The window of opportunity is closing. Between June 1941 and May 1942, German U-boats sink over 700 Allied merchant ships. The modifications Margarete designed save perhaps half of those attacks from failure. By conservative estimates, her mathematics added 300 confirmed kills to the German total. 300 ships that would have survived now rest on the ocean floor. 12,000 Allied merchant sailors who might have lived are dead. But her corrections also make U-boats more effective hunters, which means they're more valuable targets. Allied anti-submarine forces prioritize U-boat destruction. Between January and June 1942, 32 U-boats are sunk, nearly half the operational fleet. The submariners who survive owe their weapons' reliability to Margarete's equations. The submariners who die are killed partly because those same equations made them too dangerous to ignore. In London, Churchill reviews the shipping loss statistics and makes a stark assessment. The U-boats were defeated not by any single weapon, but by the cumulative weight of many. Convoy systems, air cover, radar, code breaking, escort carriers, hedgehog depth charges. The Allies don't counter German torpedo improvements with a single solution. They counter with systemic change, spending billions on technologies that won't mature until 1943. By mid-1942, the strategic picture has shifted. Germany's U-boat fleet is larger and better armed than ever, but Allied defenses are catching up. The Battle of the Atlantic becomes a race between German submarine production and Allied countermeasures. Margarete's torpedoes gave Germany 12 months of advantage. Those 12 months nearly broke Britain's supply lines, but they weren't enough to win the war. In July 1942, Margarete is summoned to a quiet office in Berlin. The man waiting isn't military. He's from the Reich security main office. "Fräulein Ziegler," he says, "your work has been invaluable. But there are concerns about operational security. Too many people know about the torpedo modifications. Too many people know your name." She understands. She's become a liability. The woman who saved the U-boat fleet knows too much, has seen too much, represents too much institutional embarrassment. "What happens now?" she asks. "Reassignment, administrative work. You'll be comfortable, but your contributions to naval development are complete." It's not a request. That night, she burns her notebooks, every calculation, every equation, every correction protocol. If they're going to erase her from history, she'll erase the evidence herself. All that remains are the torpedoes still hunting in the Atlantic, still sinking ships, still carrying the invisible signature of her mathematics. But the story doesn't end with her exile. Because what happened to Margarete after 1942, how she survived the war, and what became of the woman whose calculations killed 12,000 Allied sailors and saved perhaps as many German submariners, that final chapter has been buried in classified archives for 80 years. In Part 4, you'll discover the truth about Margarete's fate, the moral price of mathematical genius in wartime, and the lasting legacy of weapons designed by someone who never wanted to fight. You'll learn how her work influenced post-war naval engineering, why her name was erased from German records, and what she did when the war ended, and she finally had to face what her numbers had done. This story has one final chapter. One that history tried to forget. One that asks the question every scientist must eventually answer: when knowledge becomes weaponized, who bears the responsibility? The answer is more complicated than anyone imagined. In parts 1, 2, and 3, we followed Margarete Ziegler from obscure mathematician to the woman who fixed Germany's torpedo crisis, survived institutional resistance, proved her calculations in devastating combat trials, and watched as her corrections turned the Battle of the Atlantic into a slaughter that nearly starved Britain into submission. Between June 1941 and May 1942, her equations added 300 confirmed Allied ship kills to the German total, sent 12,000 merchant sailors to the bottom of the ocean, and gave the U-boat fleet 12 months of technical superiority. But what happened to the woman behind those numbers? What became of Margarete Ziegler when the war ended and the killing stopped? This story has one final twist, one that history tried to bury, one that reveals the true price of mathematical genius in wartime. Because success, as it turns out, sometimes comes with a cost that can never be calculated. July 1942. Margarete sits in a small Berlin apartment reassigned to administrative mathematics, a bureaucratic exile designed to silence her. Her work on torpedoes is complete. Her contributions classified, her name systematically erased from official records. The Reich Security Main Office has made it clear she knows too much, represents too much institutional embarrassment, and must disappear into comfortable obscurity. For 6 months, she processes logistics data, calculating supply routes, and production quotas work that uses perhaps 10% of her capabilities. She reads casualty reports from the Atlantic and recognizes the patterns, knows which U-boat kills were enabled by her corrections, which failures resulted from improper implementation. The mathematics of death have become her constant companion. Then, in January 1943, everything changes. The tide of war shifts decisively against Germany. At Stalingrad, the Sixth Army surrenders. In North Africa, Rommel retreats. In the Atlantic, Allied convoys begin sailing with escort carriers and long-range aircraft that make U-boat operations suicidal. The 12 months of advantage Margarete's torpedoes provided are over. Now Germany is losing, and everyone connected to military development becomes suspect. In March 1943, Margarete receives a late-night visit from 2 Gestapo officers. They're investigating defeatist activities among scientific personnel. Someone has reported that she expressed doubts about Germany's ultimate victory. The accusation is vague, probably fabricated, but in 1943, Berlin, it's enough for arrest. She's interrogated for 3 days. Not tortured, but questioned relentlessly about her loyalties, her contacts, her opinions on the war. They seem less interested in her answers than in establishing a file, creating a record that can be used later. On the 4th day, she's released with a warning. Continue your work. Keep your opinions private. We'll be watching. She understands the message. She's a hostage to her own knowledge. As long as the Reich needs her calculations, she's protected. But the moment Germany loses, or the moment she becomes inconvenient, that protection vanishes. For the next 2 years, Margarete lives in a strange limbo. She continues her administrative work, avoiding attention, speaking to no one about torpedoes or submarines or the mathematics that changed the Atlantic War. She watches Berlin slowly crumble under Allied bombing. She hears rumors about what's happening to scientists who know too much about German weapons programs. Some disappear into protective custody. Others are quietly eliminated to prevent knowledge from reaching Allied hands. In April 1945, as Soviet artillery pounds Berlin, Margarete makes a decision that will save her life. She burns every document connecting her to the torpedo program, destroys every calculation, and notebook, erases every trace of her contribution. Then she flees west toward American lines, carrying only a forged identity card that lists her as a displaced university clerk. She's arrested by American forces in Bavaria, processed through a refugee camp, and eventually cleared after cursory interrogation. The Americans are looking for rocket scientists and nuclear physicists, not mathematicians, who worked on torpedo depth control. Her expertise doesn't register as valuable. She's released. In 1946, Margarete Ziegler disappears from history. No official records track her after the war. No interviews, no memoirs, no recognition. The woman who nearly won the Battle of the Atlantic for Germany simply vanishes into the chaos of post-war Europe. But in 1952, a woman named Margaret Hoffmann appears in the records of the Technical University of Munich, teaching applied mathematics. The name is different, the biography sanitized, but the specialty is unmistakable. Pressure dynamics and fluid mechanics. She never speaks about the war. Students remember her as brilliant but distant someone who seemed to carry an invisible weight. In 1968, she retires. In 1974, she dies quietly in a Munich nursing home. Her obituary lists no surviving family, no military service, no wartime contributions. Just another German civilian who lived through the war and survived. The woman who killed 12,000 Allied sailors and saved perhaps as many German submariners is buried in an unmarked grave, her true identity known to no one. But Margaret's torpedoes didn't die with her. The corrections she calculated in 1941 became the foundation for all subsequent German torpedo development. After the war, Allied naval intelligence finally obtained intact G7E torpedoes and reverse-engineered the modifications. The reports are fascinating. American analysts note that the depth control adjustments demonstrate sophisticated understanding of pressure dynamics under variable temperature conditions. British engineers praise the magnetic detonator recalibration as mathematically elegant and practically effective. Neither knows these improvements came from a woman whose name appears nowhere in captured German records. The technical principles Margaret discovered: pressure compensation in variable water density, magnetic field adjustment for different latitudes, contact detonator. Softening for high-speed impacts becomes standard in post-war torpedo design. The U.S. Navy's Mark 48 torpedo, introduced in 1972, incorporates all three concepts. The Soviet Union's Type 53 torpedo uses similar depth control mechanisms. Even modern guided torpedoes employ variants of her magnetic triggering corrections. Between 1945 and 2025, an estimated 42 nations have deployed torpedoes incorporating some version of Margaret's calculations. These weapons have been used in conflicts from Korea to the Falklands, from Vietnam to the Persian Gulf. The total number of ships sunk by torpedoes using her fundamental corrections exceeds 2,000. But perhaps the most surprising legacy is civilian. The pressure compensation algorithms Margaret developed for torpedo depth control found unexpected applications in deep-sea exploration. Submersibles operating at extreme depths use similar mathematical models to regulate buoyancy and maintain stable descent rates. The same equations that once guided weapons now guide research vessels exploring the Mariana Trench. In the 1980s, a German naval historian named Klaus Weber began investigating wartime torpedo development and stumbled upon anomalies in official records. Production logs showed sudden increases in reliability starting in mid-1941, but no corresponding design changes appeared in engineering documentation. Modification protocols existed, but their origin was listed simply as field corrections authorized by U-boat command. Weber spent 15 years tracing the paper trail. He found Admiral Dönitz's logs mentioning mathematical consultant in 1941. He found Ehrn's memoirs referencing civilian analyst, whose calculations proved decisive. He found U-boat commanders' post-war interviews mentioning the woman from Berlin who fixed our weapons. But no name. It wasn't until 2003, when German naval archives were fully digitized, that Weber discovered a single personnel transfer order from October 1940. Fräulein Margarete Ziegler, mathematician, reassigned from University of Göttingen to Torpedo Analysis Division Kiel. From there, He reconstructed her story. The calculations, the resistance, the public demonstration, the wartime modifications, the forced exile, the post-war disappearance. In 2008, Weber published his findings in an academic journal. The article is titled, "The Ghost Mathematician: How One Woman's Equations Changed the Battle of the Atlantic." It received modest attention in naval history circles, but the broader public never learned the story. Margarete Ziegler remained even in Revelation a footnote. Yet the numbers don't lie. Conservative estimates suggest her torpedo corrections enabled the sinking of 300 additional Allied ships between 1941 and 1943. Those ships carried approximately 12,000 merchant sailors. But her corrections also made U-boats effective enough to be prioritized targets, leading to increased anti-submarine warfare efforts that ultimately sank 32 German submarines in the first half of 1942 alone. Those U-boats carried approximately 1,500 German submariners. So the final accounting is brutal and precise. Margarete Ziegler's mathematics killed 12,000 Allied sailors and 1,500 German submariners. Her equations saved perhaps 3,000 German submariners from futile attacks and wasted torpedoes. Her work extended the U-boat threat by 12 months, which forced Allied investment in convoy systems, escort carriers, and long-range aircraft that became decisive in winning the Atlantic War. In the end, her genius gave Germany a temporary advantage that ultimately accelerated its defeat. But the lesson here isn't about torpedoes or submarines or even the mathematics of warfare. It's about innovation resistance and the price of being right when institutions are wrong. Margarete's story parallels dozens of similar cases throughout military history. In 1879, British officer John Fisher proposed all big-gun battleships. The Admiralty called him mad. 25 years later, HMS Dreadnought revolutionized naval warfare using his design. In 1940, British scientist Robert Watson Watt demonstrated radar detection of aircraft. Senior RAF officers dismissed it as unreliable. By 1942, radar won the Battle of Britain. In 1965, Air Force Colonel John Boyd developed energy maneuverability theory for fighter tactics. Pentagon brass ignored him. His concepts became the foundation for F-15 and F-16 design. The pattern is consistent. Transformative ideas emerge from unexpected sources. Face institutional resistance require champions willing to risk careers and ultimately succeed not through authority, but through undeniable results. Margarete's torpedoes proved themselves in combat, and no amount of bureaucratic denial could erase 300 confirmed kills. Today, innovation in military technology follows similar paths. Drone warfare was dismissed as expensive toys until operators proved their effectiveness. Cyber capabilities were ignored until attacks demonstrated their strategic impact. Hypersonic weapons face skepticism even as test results validate their potential. The institutions have changed. The resistance remains constant. Because admitting that transformative innovation can come from a mathematician, a junior officer, a civilian analyst, means admitting that rank and experience don't guarantee wisdom. It means acknowledging that sometimes the most dangerous weapon isn't steel or explosives, but the willingness to question assumptions and demand proof. Margarete Ziegler had that willingness. She questioned why torpedoes failed when everyone else blamed the operators. She demanded data when others offered excuses. She calculated corrections when institutions defended the status quo. And she paid for that courage with exile erasure and a lifetime of carrying the knowledge that her genius had killed thousands. There's a German word for this Verantwortung responsibility that cannot be delegated or denied. Margarete bore that responsibility alone, without recognition, without vindication, without anyone to share the burden. The submarines she saved never knew her name. The sailors she killed never knew she existed. History recorded the battles but forgot the mathematician who made them possible. And here's the final twist that almost no one knows. In 2019, The German Naval Museum in Wilhelmshaven was cataloging artifacts from a recently deceased naval officer's estate when they discovered a small leather notebook. Inside were pages of handwritten calculations, pressure equations, detonator timing sequences, and magnetic field corrections, all dated 1941. On the inside cover in faded ink, M. Ziegler für die Wahrheit. For the truth. The notebook had survived 80 years, passed from one naval officer to another, preserved because someone recognized its significance even when official records didn't. It's now displayed in a small exhibit on wartime torpedo development, identified simply as Anonymous Mathematical Analysis, 1941. Even in physical form, Margarete remains anonymous. But the exhibit notes explain that these calculations changed German torpedo reliability from 30% to 90%, enabled the sinking of hundreds of Allied ships, and forced the Allies to completely restructure their Atlantic convoy systems. The notebook is small, perhaps 20 pages filled with cramped handwriting and crossed-out corrections. Yet it represents one of the most consequential technical documents of World War II. The curator who discovered it wrote, "This notebook is a reminder that history is written not only by generals and admirals, but by the quiet voices who dare to calculate the truth when everyone else prefers comfortable lies." Margarete Ziegler would probably have appreciated that. Not the recognition which came too late to matter, but the acknowledgement that truth once calculated cannot be uncalculated even when institutions try. From an obscure mathematician with a forbidden question about torpedo failures, to the woman whose equations killed 12,000 Allied sailors and nearly starved Britain into surrender to a ghost who disappeared into post-war anonymity. Margarete Ziegler proved that sometimes the most powerful weapon in warfare isn't technology, but the courage to demand that technology actually work. Her corrections turned broken weapons into decisive tools. Her calculations changed the mathematics of naval combat. Her persistence in the face of institutional denial demonstrated that truth, when properly calculated and boldly presented, will eventually prevail regardless of rank or politics. And because of her work, because one woman refused to accept that 70% failure was acceptable, the Battle of the Atlantic was transformed from a manageable problem into an existential crisis that forced Allied innovation, accelerated anti-submarine technology development, and ultimately helped win the war by making Germany's temporary advantage so threatening that countering it became the Allies' highest priority. 12,000 Allied sailors died because of her genius. 1,500 German submariners died because her genius made them too dangerous to ignore. 3,000 German submariners survived because their weapons finally worked. And millions of people today benefit from technologies from deep-sea submersibles to precision torpedoes to pressure compensation systems that trace their lineage back to a notebook filled with equations written by a woman history tried to forget. That's the power of mathematics wielded with courage. That's the price of innovation in wartime. That's why even the quietest voices, when they speak truth, backed by undeniable proof, can change the course of history. And that's why Margarete Ziegler, though she died anonymous and unrecognized, deserves to be remembered not as a footnote, but as a reminder that sometimes the most consequential battles are fought not with steel, but with pencil paper and the unshakable conviction that the numbers don't lie.